Hello, my name is Martin Pasquinelli. I'm the president of Structure and Site Inspection Services. We are a due diligence provider for the commercial real estate industry here in Southeast Michigan. Our services include doing building inspections or property condition assessments, phase 1 environmental assessments, phase 2 work. We do things like air quality testing, radon gas testing, water quality and purity testing. So today we are embarking on the topic of sick building syndrome. Sick building syndrome is something that's been around for a while, the concept of people being affected by their environment within buildings. There's been a lot of talk about it recently with the COVID era, and it has again been around for many years, and we're going to discuss some of the issues surrounding sick building syndrome and also effects and some solutions for it that have come up in recent years, and especially during the COVID era, where there's been a lot of talk and action regarding especially public buildings. So understand the causes of sick building syndrome. Sick building syndrome is by and large a reaction to environmental conditions and chemical exposure within buildings, and how it relates to people complaining about feeling ill or lethargic or other ailments that they perceive as coming from within the building that they spend several hours a day. So the causes of sick building syndrome is multifaceted. It can be from something like mold growth within a building. Colonizing mold growth is a reaction to a cellulose-based material that is sustained by moisture. So meaning that if there is leakage in a building somewhere, most of the time it's behind walls or above ceilings, things like that, mold can grow, it can spread, and then spore activity is created by the colonizing mold. The spores are then released throughout the air. People ingest the spores and they have allergic reactions. So we see this probably more than any condition within a building as far as the sick building syndrome is concerned. People will complain about flu-like symptoms or cold-like symptoms, and not understanding why or what the cause of that is. And a lot of times, most of the time, it is going to be from a mold situation. Perhaps it could even be from a dander situation. Most dander is created by skin fragments that come from people, and when it's accumulated, it can become an allergen to some people, if not most people. So the environmental toxins would be something that would accumulate and develop over time within a building. Most buildings have carpeting harbors and traps these impurities, and when they are walked over, they get kicked up into the air, people ingest them, and then can have allergic reactions. The mold issue is, again, it's fairly common to see this in office buildings, medical buildings, not so much as in industrial buildings because they don't have the materials that would foster the growth of the mold. But for example, we were doing a building inspection on a medical facility. It was an outpatient facility for one of the larger hospital groups here in Southeast Michigan. And the nurses were complaining about basically the air quality. They came to work and they had allergic reactions, and they got sick, excused himself, went home. So we were brought in to look at this building And we found in multiple areas significant mold growth from leakage that was occurring behind walls from a waistline. So it was a two-story building, and every time the toilets were flushed upstairs, the vent pipe, excuse me, the drain pipe that served those upper floor bathrooms, every time the water came down it would spray out a little bit of water onto the drywall behind the office space there. So that must have been going on for quite a while, because there was probably something like 10,000 square feet of contaminated drywall and fiber boards and things like that made up the interior finishes of that suite. That's a lot. That's a lot of mold contamination, and that is something that will cause that issue with people being affected, especially if it is the type of mold that people are affected by. And not all molds are going to be something that people react to. Every time you step outside, especially in the warmer months, you breathe in hundreds of spores literally in each breath of air that you take. So the body does cleanse itself of the mold spores just through its regular operation. However, when you are in a contained environment like a building, and you have thousands of spores in this particular area that you're breathing in 8 hours a day or more, then this is when situations occur that people become sick. And again, not all mold strains and spores are equal, meaning that everybody's heard of the euphemism black mold. Black mold is typically a description of a one strain of mold, and that's Stachybotrys. Stachybotrys is a highly toxic mold strain, and it typically grows on drywall or other cellulose-based materials when moisture is sustained at that material. So this is what we typically see when we are doing mold evaluations and or air quality, when we find highly elevated mold spore activity. So let me describe what would be a common air quality level for mold strains and mold spores. So if you do air quality testing in any given area, building, home, whatever that case may be, you're typically going to find 5 or 6 different strains of mold in that given area, and you're going to see a representative spore count of those different strains. In a clean environment, you might see spore counts of anywhere from 10 to 20 per strain. In an elevated situation, you're going to see about starting at about 500 to 1,000. That would be considered elevated. That would be considered a count where something is going on. When there has been sustained mold growth and spore activity, you will see counts in the tens of thousands. We did a building on the east side where we did air quality testing as part of a building inspection, and we found counts that they couldn't even process anymore that exceeded 1 million. That is obviously very rare, but those situations do arise. Again, that building was an office building that had some chronic roof leakage that resulted in widespread mold throughout the building. That kind of a situation you will react to literally when you step into the building, and everybody on my team at that point did. So there are those situations, but the vast majority of testing that would be conducted in relationship to inspections, you are going to be within a much more normal range. So that's what that's by and large the driving force, if you will, of what people will complain about, and what we will find will be the mold. Another consideration, especially in older buildings and industrial buildings, retail buildings, is chemical exposure. Chemical exposure can be things like chlorinated solvents. It can be petroleum products. For example, if you are in a retail building and you have a suite that is near a dry cleaners, you will have the possibility of being subject to a chlorinated solvent from the dry cleaning processes and operations. It's a very common situation today, and our state department of environmental regulatory, which is the acronym of EGLE, the Environmental Great Lakes Environment Department, the chlorinated solvents today is probably their biggest concern with regards to indoor air quality and sick building syndrome as far as its risk to inhabitants of buildings. Other contaminants, other chemical exposure would be petroleum products. So in industrial situations where they use cutting oils or cleaning fluids or underground storage tanks that hold petroleum products for various processes or operational matters, they have the ability to leach into the soil and then release gases that will cause a chemical exposure to the inhabitants of the building. Obviously, that's nothing that you want to be exposed to, that can become very toxic and can be detrimental to the health. We did a project here recently that was a large chemical company that was leaving the area. As a matter of fact, they sold the building to actually be torn down. The user was going to use the site for something different. The chemical usage of the building contained underground storage tanks, above ground storage tanks. We're talking dozens of each one of them. And what we found while doing the phase one is phase two activities is that there was heavy contamination in the soil that then resulted in gases forming inside the building. Now, the reason, even though the building was being demolished, we still had to, from the perspective of the state, was indicate what the threat was to the interior of the building in order to create a suitable cleanup protocol for the site. Another situation that we got ourselves into in the last year or so was a building that was a stamping plant. And that stamping plant had in-ground pits, 10, 12-foot pits underground that contained hydraulic oils. The pits themselves become cracked over time just from stress. The hydraulic oils then leach into the soil in and around the pits. And then over time, that petroleum product will then outgas into the building. That situation that we encountered entailed taking air quality samples for the chemical exposure inside the building, finding what those levels were, and then filling the pits and removing contaminated soils from the base of the pit. So those are some examples of the situations where it doesn't matter really what kind of building you're in. Depends on what the processes and what the building has been used for over the course of its history. The other thing that we're going to be talking about here is, in the era of COVID, what public buildings have reacted to and found to be important: schools, churches, retail centers, things like that, things that are more related to people coming into from public bases, not a private industry or something like that. And those situations are more or less based around the need to increase the level of fresh air into a building, recirculation of the current air that's in the building to basically replace and replenish the indoor air so it rids itself of buildup of those toxins that we just discussed. So that's been an important facet of the COVID era, which has really kind of shined a light more on the sick building syndrome situation and issue here in the recent past. So again, environmental toxins include mold, pollen, and dander. So mold we discussed and how that can develop over time, how it can accumulate, and how it can affect people. Most people have allergies in the summertime, and that's can be a direct result of mold and pollens being highly accumulated in the outside from plants and growing, and mold decays the plant. Basically, mold is decaying and feeds off of leaves and other plants and things like that. So it's always going to be in the environment, and you're going to see the largest counts by and large through the year in the summer months, starting in about April and all the way through about October, November. And you see large counts of mold in the exterior air. What we don't want is we don't want a situation where you have passing through the exterior to the interior, the mold, or again, something accumulating within the building that is developing a highly spore counts within the interior. Pollen is a reaction to, again, plants as well. And pollen drifts into a building or it comes into a building from people, and people are highly allergic to pollen. So when we do air quality testing in a building as part of an inspection, we are looking for pollen counts. Most buildings throughout the year will have very, very low counts of pollen. Those buildings that do have higher counts of pollen, it will be coming from their recirculation system, bring it in without being filtered or being poorly filtered. So pollen counts are one of the high-level allergens, if you will, and they are counted on a per fragment basis. And a typical pollen count, if you will, in a building in any given area might be 15 to 20. High levels of pollen would be in the 100 to 200. So not a high count type of contaminant, but nonetheless, even those low counts will have effects on people. Again, dander, as we discussed a little bit earlier, dander comes from a wide variety of humans and animals. And you know, you say, well, I go to a building, there's no animals in here, how come I have a high dander count? Well, it's from people. People shed skin cells and skin fragments all day long, and they accumulate, and they are relatively large particulates. So good filtration systems within a building's HVAC system will pick those up and reduce those. But if the HVAC equipment is not well maintained, or the filters are of marginal quality, then dander levels will increase. And dander is a small particulate, but it also accumulates very quick. A clean environment will still have 1,000 counts of dander. A high dander count would be 10,000. Anything in between there would be a moderate count. Dander is fairly easy to reduce, again, through filtration, through better cleaning, through better equipment, such as vacuums. Cheap vacuums, just basically by and large pull something out and push most of it back into the air. So mold, pollen, and dander make up the 3 high-level allergens that we find in buildings. And again, mold being the most common ailment that affects people from a health perspective. So we're going to talk a little bit more about the chemical exposure, just because this really has a lot to do with the commercial real estate industry today. Eagle, again, which is Michigan's Department of Environmental Quality, has significantly changed in the recent past their levels of concern and their levels of contaminant that they find to be a risk to people's health. And they have significantly modified that, and they are very adamant about buildings with high levels to be remediated. Remediation from chlorinated solvents or petroleum-based products can be very expensive to do. They can be $20 a square foot from exposed areas and or affected areas, and that's expensive. When you're talking about a building that might have 10 or 15,000 square feet of affected area times 20, you're talking about a lot of money there to remediate that. And that happens all the time. As a matter of fact, it will affect the ability for somebody to finance a building or even become approved for financing of a building. A lot of times banks won't even touch a building that has chlorinated solvent or petroleum-based product exposure or affected exposure, I should say, because sometimes it's not, sometimes you can have these issues, but it doesn't reach the level of exposure that needs to be dealt with. So when you're doing a building inspection or a phase one, a lot of thought and questions have to be asked about how is this building being used? How was it being used? What is the potential exposure to neighboring buildings or suites? In the state of Michigan, a migrating contaminant from a neighbor's building or a neighbor's site is not considered a recognized environmental condition today, with the exception of the chlorinated solvents and the petroleum-based products that can release the toxic gas into a building. So even though we have that luxury of not being affected by migrating issues, it does depend on what the issue is with regards to the contaminant. Petroleum-based products here in Michigan is probably the more relevant exposure issue, but chlorinated solvents is the hot button, if you will. We have a lot of industry in Michigan. Obviously, we have a history of not regulating that industry very well, 50s and 1950s and before that. As a matter of fact, we were doing a phase one on a building in Ferndale a couple of years ago. And during our due diligence, we actually found pictures of employees of this facility throwing waste oil into the rear alleyway over the course of the history of the building. So obviously that wasn't very well regulated or wasn't very well maintained from a waste oil perspective. So again, that resulted in doing some more phase two work, and it just became more of a problem for the person wanting to buy this building because of what had happened 60 years ago. But those are the things that we run into, and those are the things that can and will cause chemical exposure to buildings, and without having any idea of how that could have occurred. But again, good research, good data all help regulate the phase one or the phase two process in order to find those things and then make the necessary improvements and changes to the site in order to safeguard and protect those inhabiting the building. So With regards to COVID and some of the other airborne risks that's been associated with COVID, is again more or less the public buildings. Public buildings are really at a higher risk for sick building syndrome because of its use. You have, I'm going to use schools as an example. You have hundreds, if not thousands, of people entering these buildings on a daily basis. There is, ongoing interactions, physical attributes, touching, close proximity to people, shared bathrooms, shared doorknobs, all those things that we learned about in COVID and tried to guard against as we got through that calamity. So what schools have learned in a very short period of time here was that their recirculation systems were either non-existent or highly limiting. We did a series of school inspections during COVID. We did 30 building inspections for schools. Out of the 30 buildings that we inspected, only 2 of them had what we would have considered to be sufficient recirculation, venting, and exchange of fresh air to the building. So what schools are looking at is trying to introduce some type of situation and equipment where they can add better circulation to their environments. Unfortunately, it's very expensive and budgets don't necessarily account for that. Not only that, but schools by and large have central heating and cooling systems. And what that means is they might have a boiler, they might have if they have air conditioning, they might have a chiller or some type of cooling tower. Usually they just have a boiler. And as you know, boilers heat up radiators and they don't move air. So these buildings with just central heating systems are much more prone to having the accumulation of contaminants that then hang out in the buildings and get passed and get breathed in and just accumulate over time. So with the introduction of better circulation of fresh air and stale air, getting the stale air out, getting fresh air in, and circulating that air through the building in a manner that helps break down and get trapped by filtration, stimulates a better environment. Other buildings that were built, office buildings in particular, built in the 60s and 70s, also have, a lot of them have central systems. So you'll have a boiler that might have an air handler. Those air handlers, by and large, take the hot water through the boiler. It goes through a radiator type of system. The air is blown through that radiator, extracting the heat out of the water and taking it through the ductwork of the building. That does not circulate air. That basically just moves the warm air that you're creating. These buildings will also then have cooling towers and chillers that are doing the opposite thing, but in the exact same way. Basically chilling the water and sending air over a radiator and picking up the cool air and passing it through the ductwork. So when you have a situation like that, not only are you dealing with the air that can be contaminated by multiple things that we've just discussed, now you're talking about a water situation. The waters will contain molds, it will contain other byproducts that are in the air. And those get, again, recirculated through that system and can and will accumulate within the air of the building. Chillers in particular need to be frequently, the water and their radiators need to be frequently cleaned and treated. So things like these impurities and other like diseases like Legionnaire's disease don't develop and pass through to the inhabitants of the building. When you hear of a Legionnaire's breakout, it's always from a chiller. That's how that gets passed through. So I can't tell you how many times we've been doing inspections and we'll find a cooling tower, and the cooling tower radiators, they sit outside, and they will literally have moss growing within them. The water is passing through that, the air is going by it. So any contaminant like that that's being built up is going to have a direct relationship to who's breathing that inside the building. So again, proper ventilation, filtration. When we step back to that air handler for boilers and for chillers, those have filters. And I've seen many filter changeouts in these situations, in this equipment, and most of them are paper thin. They are changed out and utilized to trap these airborne contaminants. And what most building engineers don't want to do is put stress on the fan motors. So they use very light, not dense, if you will, filter products. And what that does is, again, it allows a lot of the bigger contaminants to pass, or smaller contaminants, we should say, pass through. It picks up some of the bigger contaminants, but allows a lot of the smaller contaminants to pass through. So you will see these filter changeouts on this equipment, and they are what I would consider to be very marginal style filters. We all have filters on our home heating and cooling systems, and you can see those 4-inch filters. They're pleated. You can see when they need to be changed out. They turn color, they turn gray, and you change them out. In the most building situations where you have these filters, they're 1 inch thick or 2 inches thick, and they're not dense, and they can be changed out once a year versus maybe every 3 or 4 months that they actually need to be changed out. So another issue that has raised its place here in the COVID era is the need for more rampant filtration changeouts and better quality filters. And it's kind of a mundane and kind of a simplistic approach and issue, but it is highly effective. So I imagine if you have a filter that is only grabbing 25 or 30% of the particulate passes through it. Now, no filter is going to grab 100%, but nonetheless, you certainly want a filter that's going to grab 60 or 70%. And if you have filters that are only grabbing 25 or 30% of the contaminant that passes by, you certainly don't have to change that out very often. So a lot of buildings, management companies, or HVAC companies, yes, they'll go out there and they'll change it, but they're using the cheapest products that they can buy, unfortunately. And I'm not saying every one of them, but a lot of them do that. So in the lovely COVID era that we all just went through, again, there's been a re-emphasis of what sick building syndrome can do to us and pass through to us. Everybody's obviously worried about being affected by COVID. So a lot of things have been done, at least introduced, but not a lot, based on my experience, has actually been done with regards to these public schools and churches and other sites that people accumulate to in mass. So hopefully we will see that going forward, but we all have short memories, and COVID will become something we put in the rearview mirror here, and we'll probably get right back to doing the same stuff that we have been doing, unfortunately. Okay, so the second segment of this presentation is the property condition assessment. The property condition assessment is just what it says. It's basically a fancy name for a building inspection, but that's what it's called, a PCA. And what the PCA can and does do is it finds a lot of the issues that we just talked about and goes to help the situation by identifying it, quantifying it through indoor air quality testing, things like that, and then offering solutions to remedy the issues. So what does it entail? It entails a physical review of a property. So eyes on, evaluation of the critical components of the building, that being everything that makes up a building, the structure, the substructure, the superstructure, the roof, its components, the exterior, the interior, the plumbing situation, the heating and cooling situation, electrical. All those things are evaluated by a physical review on site of a building and evaluated in its entirety to come together with basically a story on how this building is in a given time frame. And how can it help? It can help by, again, identifying and determining what is causing a sick building syndrome issue and how it can be eliminated. So when we were doing an exterior building inspection, we always start outside because exterior conditions are going to determine what's going on inside the building, just like your house, right? If something's going on outside, it's going to affect the living space inside. So we inspect the roof. Most buildings, most commercial buildings have flat or semi-flat roofs. Flat roofs are notorious for leaks. They don't have good drainage. I'd say the vast majority of roofs built pre-1980 are true flat roofs. Roofs built post-1980 started to rely on proper slope of the roof structure to drains. That helps considerably by not allowing water to pond in low or flat areas of the roof. When water pounds on any substrate, be it synthetic rubber, which is a black roof, PVC, which is a white roof, or even an rolled asphalt shingle roof, the water will eventually break that material down, find voids in the seams, penetration points, patches, and make its way into the building. So what we're looking for with regards to roofing is, what is its overall condition? How is it sloped to drain? What is the age of the roof? All roofs eventually break down. A typical decent membrane roof system has a 25 to 30-year lifespan. A marginal quality roof membrane, such as rolled shingle, will have a lifespan of 15 to 20 years. So building owner, building manager will select a roof product based on cost and what their anticipated longevity of that building is going to be for their use. So the other thing that we look for in roofs is flashing. Flashing is a significant component to how a roof is put together and how it will avoid leakage over the course of time. Then we also find out where those roofs are draining to. Most commercial, industrial, office buildings will drain internally. They actually have drain pipes that go through the building and into the storm drains beneath the building. We find a lot of internal roof sumps and pipes that leak. They they move. Basically, these pipes and these sumps move. They expand and contract. Weather changes, processes of the building, vibrations, things like that, they can move. So flashings can become weak. They can become filled with voids. And when that happens, you get leaks. So a lot of effort is looked at how that roof is draining, where it's draining to, and its effectiveness. Windows and doors, those are another big component to water infiltration to a building. So imagine you're looking at a building that might be an office building, or the front part of an industrial building or something where they have engineering space or office space, and it is nothing but glass. So those glass curtains have a lot of opportunity to leak. They flex, they expand, they contract, especially here in Michigan's lovely weather where we have 0 to 100-degree temperature differentials. So that metal and glass is always flexing, expanding and contracting. That will break down the caulking, that'll break down the sealants that are used inside the window frames, and that can and will allow water penetration. Water penetration can occur from the top of the window frames, it can occur at the lintels, and it can occur at the actual windows themselves. So we spend a lot of time looking, when we do an inspection, we spend a lot of time looking at things like the caulking, like the deflection of the window frames themselves, of the lintels, what their condition is, the sills, any brick that might be adjacent to the window frames. What is the separation of those materials, things like that. The part of the exterior building inspection will also include pavement. So parking lot, driveways, walkways, load bays, retaining walls, masonry fences, all those would be considered pavement, flat work, if you will. That can be a very expensive component to a building to replace or to maintain. Imagine a 100,000 square foot building that has 60,000 square feet of pavement. If that has to be replaced, you're probably looking at $300,000 expense. Asphalt pavement lasts about 15 to 20 years if it's got heavy vehicular activity. So when we're going through a building inspection, we pay a lot of attention to the condition of the pavement, its expected lifespan, its expected replacement cost, and we would include that within the building inspection report. Another exterior component is, by and large, can be, I should say, is HVAC equipment. So heating, ventilation, and air conditioning. Most modern buildings have rooftop package units that provide heating and cooling to the building. We inspect those units, we ascertain their age, we ascertain their capacity, we ascertain the areas that they service. We report on the functionality, we report on the level of maintenance, we report on the expected lifespan that remains with that equipment. That equipment is very expensive to replace. Rooftop unit is anywhere from 4 to 30 tons worth of equipment. That replacement value is about $3,000 a ton. So that equipment is very expensive for somebody purchasing a building that might have to come in there and replace 100 tons of equipment. So that is an important feature from a building acquisition, and also to the sick building syndrome, as we discussed earlier. When we're inspecting the interior portion of a building, we look at how this building was built from the interior. So what is the structure of the building? Is it being compromised? A lot of buildings today are built with block as the load-bearing wall system, and you have structural steel that makes up the roof system. A lot of times if you have roof leakage, it affects the load-bearing block. It can actually deteriorate the block internally, make it weak, make it settle, make it step crack. Mortar can become loose. It can compromise everything above it. So if load-bearing wall systems are compromised, then it becomes very expensive to deal with those repairs. The plumbing system, we evaluate what kind of pipe serves the building as far as its supply plumbing. Older buildings have lead pipes. Obviously, lead is a concern for people ingesting water. We look at the supply piping serving individual bathrooms, sinks, showers, whatever the case may be. We do a flood test on plumbing. We operate the plumbing at a maximum level, so to speak. So we run everything simultaneously for several minutes to put a heavy load on the system and make sure that we're still getting proper water flow, that we're not encountering leaks, that everything is exiting the building properly. With regards to plumbing, we also do what are called sewer drain scopes. So we would locate the main clean out to the plumbing system that will connect the building from a drain perspective to the municipal sewer line. We will then send a video camera on a cable through that system all the way down to where it connects to the city. So we are looking for the integrity of that drain pipe. That drain pipe can consist of construction materials such as clay, cast iron, PVC, and in some points, something that's called Orangeburg, which is basically a cardboard wrapped in tar. So obviously that's a very important component to a building. Everything has to leave the building and find its way to the municipal sewer system. If you have damage or obstructions in that pipe, it can be very expensive to repair or replace. So that is a very important aspect of a building inspection. We look at the electrical system of a building. The electrical system is by and large configured to a building's use. So if you are in an office building, you're not going to have the same electrical needs as you would if you were in an industrial building. So the electrical system will be evaluated for the current usage of the building and discuss with the client if they would change the use of the building and what they might need to do to the electrical system to update or otherwise upgrade for that system. Electrical hardware will vary in its age as far as its usefulness. It does have a lifespan. Old equipment does become finicky. It does become problematic if you're putting a high use on it. So we evaluate for age, we evaluate for overall input as far as voltage and amperage is concerned, and then again, the usage, what it's going to be used for. We also spend a lot of time with life safety issues. Life safety, it consists of if a building is suppressed. The suppression system is a sprinkler system. So a lot of buildings today are all built with suppression systems. Suppression systems are required to be certified by independent companies on a 1- and 5-year basis. So on a suppression system, we look for those certification tags, make sure that those are up to date. We make sure that we have positive pressure on the suppression gauges. We make sure that there is spare sprinkler heads in stock. So if they need to be changed out, they are readily available. We look at the fire panel, make sure that there's no active alarms or error codes. Then life safety also includes things like fire extinguishers. Those are required to be certified on a yearly basis. Each hallway, each stairway needs to be served by battery backup light fixtures. So if if the building loses power, then these lights come on in those vulnerable areas via battery. We also look for things like strobe packs in bathrooms. If again the building loses power, these strobe packs come on in the bathrooms and other parts of the building to alert that there is an issue. It's also for deaf people, so they can see that. Other life safety issues are crash bars on egress doors, ductwork, smoke detection systems, things like that. Now, all buildings have great life safety, but more and more we're seeing, and especially modern buildings, a much better approach to including those life safety issues. Another aspect that we deal with is ADA compliance. So ADA is Americans with Disability Act compliance. That was early 90s legislation. Any building built prior to 1992 does not have to subscribe to ADA compliance. Anything built after that time frame has to comply to ADA compliance. So ADA compliance consists of having proper parking lot access, defined parking lot demarcation for ADA wheelchair accessible parking spaces, curb cuts, so a wheelchair can access the walkway, elevators have to have Braille text on their external call buttons and their internal call buttons. Elevators have to have a specific size in order to accommodate wheelchairs. Bathrooms, restroom ADA compliance consists of handles around the stalls. Internal stalls have to be a proper size to allow wheelchair access to that. You have to have scald guards on your faucet traps. So if somebody wheels themselves up to a sink and hot water is running through the trap, they don't burn their legs as they're underneath the sink. And drinking fountains. Drinking fountains have ADA compliance as well. Other interior building issues, obviously, is water damage. Water damage is, again, probably the biggest component that we're going to see relating back to the sick building syndrome concern and issue. When you have ongoing leaks, it creates all those issues. If you have poor circulation, again, it creates those issues. A lot of buildings today modern buildings don't have windows that are functional. They are fixed pane windows, and that's by design. That's because they can control the circulation of the heating and cooling equipment much better if they don't have interference from outside air in different areas. So imagine you're trying to create this loop of air between your recirculation system and people have windows open and it's trying to draw in from those different areas. It's going to rob Peter to pay Paul, and that's not going to work very well. So most buildings today have fixed pane windows, and you will not see windows that are functional due to those concerns. So again, environmental testing consists of indoor air quality, trying to ascertain not only what is in the air, but where is it coming from. So indoor air quality is very good at identifying those contaminants and also identifying where they're coming from. So even if it's behind a wall or above ceiling tiles or something like that, indoor air quality is very good at isolating where the elevated contaminants are coming from. Water quality, even in our area where we have good water quality, lots of things can affect water quality. So we'll do water quality testing for various reasons. A lot of it is to see if certain types of pipe like galvanized steel or lead piping is affecting it. Even PVC piping can affect quality of water. If we're in a rural area where the building is on a well, that has its whole set of issues that can be related to fertilizer runoff, to lead, to PCBs, all kinds of things that come from orchards and other contaminants that can filter down to reservoirs that then get picked up by wells. Another significant air quality issue is radon gas. Radon gas is a byproduct of decaying uranium. It is found in all buildings, houses, dwellings. If you have a contained structure, you have radon. So radon, again, is a byproduct of decaying uranium. It is a gas material, and it filters into buildings through cracks and slabs, through drain pipes, through floor drains, things like that. And then because it's heavier than air, it accumulates in the lowest part of the building or structure. Radon gas is the second leading cause of lung cancer, and it should not be taken lightly. We do a lot of radon gas testing, and we have and do find high levels of radon in many places around the state. I always like to talk about this one situation because it's a very sad situation to me personally. I knew this real estate agent, and he worked out of his home, and he worked out of his basement. That's primarily where he set up his office. And I met him on site one day and asked him how he was doing. He said, not doing real well. I was just diagnosed with stage 3 lung cancer. He says, never worked a day in my life. Never smoked a day in my life, excuse me. And we said, well, you know, I know you work out of your basement. Let's go test your radon gas levels. So we set radon gas equipment, tested gas equipment that day. His numbers were off the chart. So unfortunately, he passed, and it was a direct relationship to his high radon levels. So a lot of people poo-poo radon, but I've seen the real negative side of it. And we always encourage people to do radon gas tests, especially in commercial buildings, because you have a lot of people that are in your buildings, and people are subject to being exposed to that threat on a continuous basis. So that is my presentation. I hope you found it not so boring. Again, my name is Martin Pasquinelli with Structure and Site Inspection Services. Here is our contact info. We service Michigan. We also service outside the state for various clients. So if we can be of any help, don't hesitate to give us a call. Appreciate your patience. And if you have any questions, don't hesitate to call me directly. Again, thank you for your time.